Hello, in this lesson we're talking about descriptive measures of statistics, and in this particular video we're talking about measures of center. So let's hop right in. You might grab your calculator or you might pull up Fathom if that's what you choose to use, and get this going, sharing a different way. So hopefully it works, hopefully it's as effective. So you should be seeing my screen, and this is descriptive measures. So measures of center, numbers that are used to describe data sets are called descriptive measures. Sorry, I ran over a little bit. So measures that are used to describe are descriptive, kind of redundant. And the measures of center describe, you guessed it, the center, or the most typical value in a data set. So the measures of center that we're going to look at today are mean, median, and mode. And it looks like I forgot a parentheses right here. We'll just put it in there. And you'll notice out to the side something that I wrote, and this is important. Mean is only used for quantitative data. Median is only used for quantitative data. Mode can be qualitative or quantitative. So that was one of the things that I mentioned when we were deciding what type of variable something is. If you can find the mean of it, then that's an indication that it is a quantitative variable. And remember, quantitative is a variable that describes, or a variable that is numerical. And then qualitative is non-numerical. So mean and median, again, I just want to stress this, mean and median only apply to quantitative data, whereas the mode can be either or. So one of the examples I have here is, why wouldn't it make sense to find the mean of a data set composed of zip codes? Zip codes are numbers, right? So if you think in your mind, if you were to find the mean, and mean is another word for average. Actually, all of these are averages, but you might recognize it as an average. So why wouldn't it make sense to find the average of a zip code? Let's say I'm assuming that zip codes are quantitative because they're numbers. And so I add up all my zip codes and I divide them by the number of zip codes and I get a number. Is that number meaningful? Not really. I mean, it is a number. I will get a number, but it's not meaningful in the sense that it can describe the center. So you have to be very careful. When I say numerical variable, we still have to consider whether, if we did find the mean, does the mean make sense for describing the data? So why wouldn't it make sense to find the mean of a data set composed of zip codes? Zip codes are actually a qualitative variable. They have these they're more like categories, or you could even substitute in the name of the town instead, if that makes more sense in your mind. I'm having an issue. Okay, sorry for that. It wasn't showing my writing, so I had to troubleshoot. So anyway, zip codes, if you can substitute in your mind the name of the town instead, you can easily see that that's a qualitative variable and it's not going to make sense to find the mean of it. So I mentioned earlier how you find the mean or average. Those words kind of get used interchangeably. You add all the observations in the data set and divide by what? How many observations there are. Oops, gonna run out of room. Observations there are. So that's in words, how to find the mean. It's a very simple process, and you've probably done it before. If you've ever taken a class before in your life and you were curious about your grade in the class, you probably found the mean. So the mean is describing, on average, if we were to look at the big picture of your grades, what is the most typical grade that you made? So if you made a whole bunch of A's and then, oops, you made a 70 or something, which a 70 isn't bad, but we'll just go with it. You made a whole bunch of A's and then you made a 70 and you're like, oh no, what's the 70 going to do to my average? Well, if you have a whole bunch of A's, then it's probably not going to affect it that much, maybe a little bit, but not that much. So the mean looks at, or the measures of center look at the most typical value in the data set, the center. And you'll see this a lot in your textbook and other places. The formula for mean, this symbol I'm going to use over and over again, and you'll see in statistics over and over again, is the sample mean. So that's the mean of a sample. And the formula looks like the sum of all the x values, excuse me, divided by n. Okay? This symbol means the sum of. X sub I means all the observations in the data set, and n stands for the number of observations in the data set. So this is just a symbolic form of this. And then the median, there's two ways you can find the median. The first way, in both cases, you have to put the observations in numerical order. In both cases, you always have to do this. So I'm going to put this here, put observations in numerical order. Always, always, always. Smallest to largest, put them in order. And then once you do that, you can just locate the middle. I usually just start from both ends and start marking out numbers until you reach the middle. Or you can find the position of the middle number using n plus 1 over 2. Now remember, n plus 1 over 2 does not give you the median. It gives you the position of the median. So which location, once they're in order, is the median number? Is it the first number, the second number, the third number, the fourth number, and so on? So for example, if we had a data set 1, 2, 3, 4, 5, we'll just say those are my numbers, and I wanted to find the position of the median number, you do n plus 1 all divided by 2. What is n? N is the number of observations in the sample. There are 1, 2, 3, 4, 5 numbers. So 5 plus 1 over 2 is 3. 3 actually happens to be the median, but 3 is not the median, the value of the median. 3 is the position of the median. So the third number is the median, which coincidentally happens to be 3. Oops. I could make that, just to make it not confusing, I could make it a 4. We'll say that's my data set. I can make it a 4 instead. And hopefully that makes a little more sense, that the third number, 3 is not the median. The third number is the median. So that's one way you can find the position of the median. I'm a little bit more used to, with small data sets, this is, pretty simple to locate. you just start on the outsides and work your way to the middle. Let's say, for example, that your data set is even. Erase this. If you need that, you can pause it and go back. Let's say we have instead 1, 2, 2, 4, 5, 7. That's our data set. And I want to find the median. And let's say I use the first method where I start on the outsides and work my way to the middle. Uh-oh, there is no middle. Well, it looks like there's no middle, but there is. It's going to be halfway between 2 and 4. Now that's kind of a simple example because you pretty much know what's the number between 2 and 4, 3. But let's say it's a harder number. Let's say you can't quite figure it out. Then you would average the last two numbers that were marked out, and you get your median. You could do, let me keep going. To find the position, there's 1, 2, 3, 4, 5, 6. 6 plus 1 over 2, 7 over 2. It would be the 3.5th, I don't know how to say that, 3.5th position, which would be in between the third and the fourth. So you still get the same number, like the same position. These two, I just want to clarify that these two ways are helping you locate the middle. And then once you find the middle, sometimes you might have to average the last two numbers to find the middle. So moving on. And then the mode, this is probably the easiest one to find. The mode is the observation that occurs the most often. So you may have cases where each observation occurs once. And so there's not an observation that occurs the most often. So there would be no mode. And there's also the situation where maybe there's two observations that both occur 6 times, and that's the most that they occur. Then there could be 2 modes or 3 modes or 4 modes. So you may have 1 mode, no mode, or multiple modes. And we actually looked at this when we were looking at distribution shapes. We talked about unimodal, bimodal, and multimodal. So that's kind of, you'll see that in the distribution shapes from my previous video. So that's mean, median, and mode. And then we're going to try, I kind of summarized it here in this table, if you need that. And then I do want to talk about, before we try stuff, I want to talk about a resistant measure. A resistant measure is not sensitive to extreme values. So it's resistant to extreme values. That means that if I were to introduce what's called an outlier, an extreme value, a resistant measure is not affected by that. So let's pretend, for example, we have, let's see, ages of people in a class, we'll just say, I don't know. And we have, 18, 19, 20, 21, 20, I'm just making up some numbers here, 22, 23, and then an 85-year-old, which is great. More power to the 85-year-old. But that 85-year-old is going to change the outcome of our descriptive measures because it's so far outside of our data set, our normal data set. And if we were to calculate the mean without it, you can see that we're kind of in the 20s. Early 20s maybe is our center, I would guess. I haven't actually found it, but I would guess just looking at it, it would be in the early 20s. And the median would also probably be in 20s, and then the mode is actually 20 in this case. But if I were to introduce that 85-year-old into the class, that's now going to skew my data. It's going to pull my mean higher because 85 is so much higher than the rest of my data that it's going to affect it. So the mean is not resistant. If you introduce, or even we could go the other way. If we introduced a 6-year-old to class, I don't know, maybe a teacher brought their kid to class, I don't know. A 6-year-old to class, that's going to skew the mean. It's going to bring the mean down because it's so much different than the rest of our data. Whereas the median doesn't really consider the values, it just considers the order of the values. So 6 wouldn't really change it, whether it was a 6 or an 85, it doesn't really change it. And then the mode, same thing, it doesn't really change it. So the measure of center, which measure of center is resistant to extreme values? Median is resistant to extreme values. So is mode. I'll say in mode. Sorry. The median is not going to be affected by having an 85-year-old versus a 6-year-old. It's still going to be the middle position, no matter what that extreme value is. The mode is still going to be 20, no matter what that extreme value is, but the mean is affected by introducing those extreme values. So the mean is not resistant to extreme values. Okay, so that gets us into skewness, which I've actually kind of talked about this before in distribution shapes, I believe, when we were talking about right skewed, left skewed, and symmetric. And I did introduce comparing the mean and median in those. And this kind of just expands on that. And this has the picture of right skewed, and it compares the mean and median of a right skewed distribution shape, because in a right skewed distribution, it has an outlier greater than the rest of the data. So it has a value out here that's affecting the rest of the data. It's pulling our mean higher than what we would expect. And then in a symmetric distribution, we don't have really necessarily any outliers that are pulling the mean in either direction. And so it's dead center. The mean and median are actually equal or close to equal in a symmetric distribution, usually equal. And then in a left skewed, we have an extreme value or outlier less than the rest of the data. So that much smaller value changes our mean because it pulls down what we might think would be the center. So for example, if you are taking a class and you have a whole bunch of 90s and 100s, and then maybe you had a really bad day and you made a 20. That 20, even though it's only at 120, it's going to pull down your average. Or even in your GPA, if you have a whole bunch of A's and then you make a D or an F in a class, it's going to really tank your GPA. And it's really hard to bring it back up after that. So those extreme values really affect your average. And I've talked about this, but we'll just summarize. Actually, if you want to, pause the video, try to fill out these blanks as best you can, and then come back and see if you got them right. For right skewed graphs, the mean is greater than the median because the extreme high values pull the mean farther to the right. So it is right skewed. For symmetric graphs, the mean is equal to the median. There's no extreme values that pull in either direction. And for left skewed graphs, the mean is less than the median because the extremely small value pulls the median farther to the left. I have an example here. I would like for you to pause it and try it on your own using the information on the previous page, and then come back and check your answers. All right, so hopefully you got these values. You can see my work there if you need to pause it and check yours. So for the mean, you should have added all the values, the order doesn't matter, and then divided by 9. You have to be careful how you type that in your calculator. You can either do it in 2 steps where you add it all up, hit enter, and then divide by 9, hit enter. Or if you type it in 1 step, make sure you put the numerator in parentheses because you're telling the calculator, I want to add all of this first and then divide by 9. And you should get 117. And then the median, if you put the numbers in order, make sure you put the numbers in order and locate the middle. That will be 116. Did I say 117? That is 117. Median is 116. Or you could have done n plus 1 over 2. There were 9 observations. So it was the 5th number. 1, 2, 3, 4, 5. 5th number. That's the other way you can do it. The mode was 154. And this was slightly right skewed. The mean is not too much greater than the mean is not too much greater than the median. It's pretty close, and but it's right skewed. And then when I looked at the graph of it, because it was so close, I don't know if you can see that, but you can kind of see it's kind of following. It's got that one bump at the end, but it's kind of following a right skew. So I went ahead and called it right skewed. Kind of a bad example, but there's that. And then the next page is how to find mean, median, mode on your calculator. So obviously it's good to know to do it by hand. It's a good way to check your work in case you type something in correctly or anything like that. But it's always, always, always a good idea to know how to use technology correctly, to use it to check your work, or just to be more accurate. There's a lot of human error when you do things by hand. And so using a calculator can oftentimes eliminate human error as long as you type in the data correctly. So always make sure if you are using a calculator, double check, triple check that you have typed your data in correctly. Not incorrectly, but input your data correctly, okay? So go back and check it and double check it to make sure that you didn't mistype anything. And yeah, so that's very important. Calculators are great as long as the user is paying attention. So these are the steps on a TI-84, and you can see what it looks like there on the screen capture. You will have to scroll down once you do the one var stats. This is what's going to show up, and you'll have to scroll down to get the rest of the stats. And remember that X bar represents the mean, and then your median is down here. It does not do mode, but mode is usually pretty easy to find by yourself. And there's some other stats in here that we will actually use later, but not today, or not in this lesson specifically. And then you can also use Fathom to find these values, and I have some instructions there on how to do it. I'll show you in just a second, actually. But there's the written instructions. Fathom's really easy to use. I will show you in a second. But what I want you to do for your last example is to use your calculator or Fathom, whichever one you have, to check your answers from this example. So you're going to input this data either into your calculator or Fathom to check these answers. Well, it won't have this one, but to check these answers. So go ahead and pause it. I want you to try it, check your answers, and see what you get. I'm going to screen share Fathom just so you can see it. The calculator one is already on the paper, and hopefully by now you're pretty familiar with your calculator and the stat edit, stat calc menu, but I do want to show you Fathom because I like it so much. So let me share. I'm getting tongue-tied here. Whoops. There we go. Share my screen. And there's Fathom. I'm going to drag down a table. I'm going to call my variable trial. I don't know. You can call it whatever. X, Y, Z, it doesn't matter. And I'm going to input my data, 96, 66, 147, 175, 116, 57, 154, 88, 154. And then you want to go through and check, make sure that you typed it all in the right way. 96, 66, 147, 175, 116, 57, 154, 88, 154. And then I'm going to drag down summary. You can see there's nothing there. It says drop an attribute here. I'm going to drop trial. I'm going to put it over here. And right now it's just found the mean. I want more than the mean. So I'm going to right click, add basic statistics. And then I'm going to right click again, add 5-number summary. And that's going to give you mean, and it highlights it. Median, and it highlights it. Later we'll learn standard deviation, and it highlights it, but it gives you all your statistics here just like it would in the calculator. And then you click on the one that you want and it highlights it. So we can see that 117 was correct for the mean and 116 was correct for the median. So isn't that fancy? That's all I have for this lesson. I hope you enjoyed it. In the next video, we'll talk about measures of variation. If you have any questions, please feel free to email me and I would be happy to help.